Welcome everyone back to another episode. Today I'm with perhaps the most awarded professor at NC State, Dr. Barrangou. Did I pronounce that right?
Barrangou.
Barrangou. He's been inducted into the National Academy of Sciences, National Academy of Engineering, the National Academy of Inventors, and the National Inventors Hall of Fame. If you're interested how impressive that is, go on NC State's websites and their awards section, and then try and find another professor that's in just two of those. And also, maybe most impressively and importantly, he got his master's and his PhD from NC State. So, true Wolfpacker. So we'll start off with, what is your job title and how long have you been teaching at NC State?
I am the Todd R. Klaenhammer Distinguished Professor in Probiotics Research here at NC State. My home department is Food, Bioprocessing, Nutrition Sciences. That's where I'm faculty of, though I have affiliations in 6 different programs and departments. And this resides within CALS, the College of Ag and Life Sciences. And I've been at NC State since 2013. So I've been here for 11 years in my capacity as a professor.
So, some background questions. When you were a child, what did you want to be when you grew up?
I had no idea what I wanted to be when I grew up, when I was a child. And I think I wasn't sure what I was going to do when I was going to grow up, even as a student.
Mm-hmm.
And as a matter of fact, that's why I went to school a number of times in different kinds of majors, because it took me a while to really figure out what I was most passionate about, most excited about. And some people, even today in my life, either in my lab or at home, might be unsure as to where I may be headed next and what I'm going to focus on. So I'm going to stay at NC State. You know, I'm married to an institution in many, many different ways, but professionally, in terms of defining, you know, what I'm going to do, what I'm going to focus on, and how I'm going to balance different sets of activities is yet to be determined. And that's one thing I really like about my career, is that I kind of reserve the right to change my mind and change my direction as science changes and technologies arise, and opportunities to translate research, science, and technology into real applications evolve in a very dynamic context and a dynamic manner.
Did your parents both graduate from college?
Yes and no. So my dad did graduate from college, but as a later onset adult. And then my mom only has an associate's degree, I guess the equivalent thereof, in Europe. So it's not quite seen or perceived as a college degree per se. But I guess they both got some college education, but very limited. And my mother was a midwife. And then my dad is more into law to some extent, but they're not really in the scientific or engineering realm whatsoever.
Did you consider taking a different path than going to college, or did you know that you were going to go to college for a long time?
I mean, I always thought I had an appetite for learning, for sure. So going to college repeatedly and over a long period of time, I think was always in the cards for me, because I'm a curious person by nature. I like to learn about things, and you know, whether you're going to get a degree or not, I guess it's practically relevant, but it's not really the main point. I consider myself a lifelong learner. That's why I went to school a number of times, again, different institutions, different majors. We'll get into that in a minute. And I always had that appetite for curiosity and learning new things. So, you know, college is a great way to do that, but it's not the only way to do that necessarily.
So when you finally decided that you were going to go to college, how did you end up choosing your major?
So I always liked biological sciences, so to speak, but I was really mesmerized by organic chemistry when I was in high school. So I did my first degree, my first undergrad, kind of in chemistry and organic chemistry. And I loved, you know, the beauty of the periodic table of elements. I love organic chemistry. You know, it's kind of perfect in many ways, and rational and intriguing and beautiful, and practical to some extent, but for career development, career management, career trajectory is very limited. So I kind of decided after my undergrad in chemistry to go into grad school for an engineering degree, because engineering is very broad, very applicable, very relevant, very translatable in a number of professional avenues and pursuits. And I think of myself as an engineer in many ways, because I'm again a trained engineer, biological engineering, chemical engineering as a master's degree. But I always found the dogmatic part of engineering very restrictive and very limited. There's a rule for that, there's a principle for that, there's a law for that, there's an equation for that, there's a model for that. And I think it was in many ways missing or lacking some ambiguity, some degrees of freedom, and some creativity. Yeah. And so after I did my master's in engineering, I came to NC State to do a master's in food science, and food microbiology in particular, and looking into microscopes and getting exposure to biotechnology and molecular biology. I was just fascinated by the mystery of the living. When you look into a microscope, you see things you can't see with the naked eye. You kind of unravel a whole new world. Yeah. And then at a time when manipulating, the DNA content, their genome, their genetics, to rewrite the code of nature and change organisms that are living in real time, in real life. That was very mysterious, very mesmerizing, very exciting, very adventurous. And then I decided then to do my PhD in genetics and genomics at a time, late 90s, early 2000, there was a golden era in using sequencing to determine the genetic content of the human genome, amongst other things, and evidently bacteria and viruses and the like. So I decided to do my PhD in genetics. And I would consider myself like a geneticist, probably more than anything else, though I'm an engineer and organic chemist and a food scientist. And I have no degree in microbiology, but I consider myself a microbial geneticist, so to speak. And then after that, we'll talk about that in a minute, but I went to the real world industry. And in the midst of that, I decided to go back to school, part-time, weekends and nights, to do an MBA, to kind of learn about business, learn about decision-making, learn about leadership, learn about finance and marketing and operations and the like. And so I was, finally going to school and entering into a new major to complement your knowledge, learn new things, discover new things, and appreciate the world through a different prism was always something that I thought was important to me. So I think I'm done with schooling for the time being, but you never know what the future holds. And that curiosity to kind of change majors over time helped me, kind of have different viewpoints in the world, whether it's, again, chemistry or physics or engineering or math to some extent, and computer programming and the like. So, there's a lot of different curricula, lots of different classes that have a lot to offer, and I think complement each other, as opposed to the one-dimensional, do your undergrad and your master's and your PhD and your postdoc in one discipline. And they're going to stick to it. I never had that love of one particular discipline per se. It's more limiting, it's more limited, and I like the broad spectrum complementary additions inherent to learning. Different majors, different classes, different professors, different institutions, different teaching methods, different teaching metrics, different teaching types, and different testing types. So I think a broad education in that sense is much more preferable.
How did you decide, so you went to undergrad in France, and how did you decide to get a master's degree in the US? Did you consider getting a master's degree or a PhD in France?
Absolutely, yes. So I do have my first master's in engineering from Europe as well. Yes, and I changed the institution from Paris to the north of France, so to speak. And when I decided to get another master's, I was quite ready to commit to a PhD after my first master's, because I knew I was going to go overseas. I think I applied to 27 different institutions in like 15 different countries or something.
Well, why were you set on going abroad?
Change your perspective, literally, right? Yeah. Broaden your horizons.
Yeah, so it's like the same thing as like changing majors, changing locations, really
exactly
trying to get the full breadth of.
Absolutely. So, I was born and raised in Paris to some extent. So big city. I wanted to go someplace that had no subway. It was small enough where there was no subway.
Interesting.
Right, that was took the subway
That's
for many
that's
years.
such an interesting criteria.
So we had to have like an international airport. You go
Yeah.
somewhere international directly, so big enough to have that, but small enough it wouldn't have a subway. And then it would not be a French-speaking country, so like not Switzerland, not Canada, Brazil, Quebec, and a few parts of the world that still speak French from colonialism. English was preferred, right? So there's some limitations. There's a lot of part of Europe where you can, even if English is not the primary language, you can get an education in English.
Is that because like most, or like a lot of research papers are published in English, and you're trying to perfect your English?
Well, absolutely. So I thought I hope my English was good enough at the time, but it wasn't perfect, evidently. But most scientists use English as their primary research language.
Mm-hmm.
And the scientific community communicates primarily in English. So if you look at powerhouse like China today, who's producing a lot of scientific research, right? The bulk of what they publish is in English. When they present in English. When they write, they report, they opine, they communicate, is mostly in English. And though that is the truth today, I thought it was already the truth in the 1990s.
Yeah.
Right, at a time when most scientific journals publish in English. You can publish some in French, but who's going to read that? The French and the Canadians, right? So I thought that was obvious. So there was a few cultural criteria, linguistic criteria, scientific criteria, the type of institution, the type of country, and then in the end, I had a number of options to come to universities in the U.S. and Raleigh was just special, right? The weather, the people, the institution. Couldn't be too cold, couldn't be too small, couldn't be too big. We had to have a good engineering school because that's where I came from and I was valuing a lot. So we checked all the boxes, and then visiting it was just like a literal life-changing experience. I remember coming out of Terminal 3 when it existed. It's been torn down ever since. But in 1998 when I came down, I remember coming out of the terminal and smelling the pines and feeling like I'd been home, though I'd never been here.
That's like crazy.
Your life flashes before your eyes upon the first breath. And it's very hot, it's very humid. I was not used to that whatsoever. But I had the sense of belonging when the doors open. I remember like vividly the moment when the doors open and take that first breath. And I kind of knew back then that was going to be special, but I didn't know at the time whatsoever that I was going to be here for a long time, let alone that I'd meet my wife and have a job, and I thought I was going to be here for a couple of years, get a degree or two, and then move on.
So after you got your PhD, how you ended up, eventually you worked at a dairy company, sort of like a research firm in Denmark. What was the time between you graduating and you going to work there?
0.
Okay, so you went immediately.
Directly, yeah.
So my first question is, how did you decide that you wanted to go into the private industry, and then how did you decide to come back?
So I always knew I had to drive to do what's called translational research. I wanted to translate my data, my knowledge, my expertise, products that I work on, technologies that I work on into the real world. And as a matter of fact, my PhD was partially funded by that company.
Oh, that's cool.
So I knew those people, I knew their products, I knew what they were doing, I knew what they were working on. Though at the time it was a French company. The name has changed, many a time, as a matter of fact, over the years, shortly after I was there, they were acquired by DuPont, so a Fortune 50 company. It's now IFF, International Flavors and Fragrances. And before that, it was Rhodia and Rhone Poulenc, and different names they've had over time. Changing dynamic. But I always knew I wanted to work in industry, work on real problems and real products to make a real difference in the real world. And that was the case when I left, my PhD to go get a job there. 9 long winters in Wisconsin, with its advantages and caveats for sure. And then I knew that that I really wanted to do a lot more science than they allowed me to do there, even as a global R&D director for a whole division.
Wow.
Large team and large budget, large portfolio, lots of resources. I felt limited in my ability to really advance the science and the technology in ways that were going to serve more than just one set of shareholders and stakeholders.
Had they begun asking you to like do? Were you still doing research? Was it the research was too focused, or they had kind of begun to ask you to do the same thing over and over again?
It wasn't redundant. It was changing, because if it was too boring, I would have left it a long time before that. But they were very focused on one corporate agenda, right? So one set of products, one set of customers, one set of solutions. And though some of the innovation was sizable and interesting and relevant, a lot of it was incremental.
Yeah.
And risk management and risk taking and more adventurous part of disruptive innovation, they had a limited appetite for that. They did some of that. We did some of that very well, as a matter of fact. But the realm in which it was applied and the scale at which it was deployed was somewhat limited. And I had a couple hundred people reporting into me. We built a lab in Shanghai, China. I had a team in France, team in Denmark, team in Finland, a couple of teams in the US. So it was very enjoyable, very productive, very fruitful, very engaging, and interesting from a research and development standpoint. But I felt limited in my ability to truly explore the science and develop the tech, and then pursue interests that went beyond what the one corporation was focused on. And that's one of the reasons I came back to NC State, to run my own lab here, and then also focus and deploy my expertise, my knowledge, my know-how, and that of the lab and the institution to tackle almost bigger, grander, more challenging issues and problems. The grand challenges that fall before us here: to feed the world and cure disease and have sustainable forestry, and grandiose things that not any one corporation can do, and then have a bigger impact. And I felt as though my ability to be impactful practically was relevant for one commercial entity, but it was limited in scope. Whereas having the freedom to operate as a faculty member who's tenured at NC State, and I can pursue whatever I want to pursue as long as I can secure funding for it and compel people to work on it with me.
Yeah.
Collaborate and hire the students and the trainees and the workforce that we need to do that. Behoove them and compel them to work on that is exciting. Is a task at times, nonetheless. But I felt as though I could do a lot more than meet the scope of expectations of any one corporation with one corporate agenda, mostly short term.
So I watched a documentary online about CRISPR and about your work. So there was a big CRISPR paper that you and your team published while you were at that company, and that sort of seems like that paper sort of opened up the field. Was CRISPR known before that paper, and what did that paper do to really popularize CRISPR? So
CRISPR was known, but nobody knew what it did.
Oh, okay.
So it had been observed, it had been detected, it had been visualized, it had been baptized, it had been discovered. But what we did was discover the function of CRISPR, demonstrate its biological activity in the real world, and then uncover critical parts of how it works and how it can be used and applied. So that kind of established the field in many ways. It allowed us and a lot of other people to commercialize the CRISPR system, the CRISPR-Cas immune system, the CRISPR molecular machine, so to speak. And we also discovered a famous enzyme that subsequently was named Cas9, which has revolutionized the world, and that enabled other people to repurpose it and develop it as a very useful technology. So I think the work that we did in the early to mid 2000s was very foundational and very fundamental and very useful and led to a lot of applications, but it did not at the time have the grandiose impact that it had subsequently, because other people came in and complemented our knowledge, our expertise, our know-how, our insights, and really developed the tech in a more revolutionary way than we did.
Mm-hmm.
And that is what democratized that technology and changed the world.
Yeah, I saw, so I think that your paper came out in 2007, and Jennifer Doudna and Emmanuel Charpentier, if that's pronounced right, they had a paper in 2011, and they have recently got the Nobel Prize for that. So I was pretty shocked to learn that your paper came out before their paper, which, I mean, I'm a civil engineer, so I don't know much about the field. Do you think there's a Nobel Prize in your future, or no?
Probably not, no. I mean, how it's described and how it's decided and how it plays out is out of my control and out of my jurisdiction for sure. But I think Nobel Prizes recognize people.
Mm-hmm.
And Jennifer undoubtedly, unquestionably, is a remarkable individual, a remarkable scientist, a remarkable person, and has made remarkable contributions to the world. And so she used some of the tech and knowledge and foundational and fundamental insights that we developed, but she revolutionized that by having a critical invention
Mm-hmm.
that changed the world, democratized the technology, and was evidently worthy of her consideration for a big prize like the Nobel, right? So that's fantastic in her. And I think that was it for CRISPR, right? Like in the future, they can give more to other remarkable people if they make remarkable contributions that are worthy of this, but it's hard to speculate. And I think and I hope that in the realm of human medicine, they will, because there's a lot of great MDs that are developing gene therapies that are saving lives and curing disease. And now we're at the kind of the end of the beginning of the CRISPR craze, where and when the FDA, has approved, the first generation CRISPR drug, which is the first in a series of drugs that will cure disease and change and save the lives of patients. So if I had to speculate and look forward to the future and kind of foreshadow, forecast what is next, I hope that in due time the Nobel Committee or committees will consider some of those MDs that are saving lives, of patients that are otherwise dying, because they're the ones, executing the miracles of science on a daily basis and changing the world. And I think that those people would be more remarkable, more worthy, more impactful, and then more amenable and arguably defendable, right, and defensible for those kind of awards. I haven't saved a life at all. I haven't dosed a single patient. I haven't changed the world in that sense.
I mean, technically, but your work is the foundation for those things that came after.
Yeah, I mean, it's important. It's an important break in the foundation for sure.
Yeah.
Right, you're like the NC State brick imagery here, right? We'll have to do our part.
Yeah.
So certainly, we've built that foundation, but it does take a village. I think people also understand, in the eras of evolution of science, it takes multiple iterations, multiple people, multiple rounds of innovation to kind of bring something to fruition. And sometimes people who started it, sometimes people who ended it, sometimes people who did the hard work in between get recognized, and there's some ambiguity, there's some argument into who deserves what, when, and where, and how, by whom, but I think so far people like Jennifer have very deservingly received the accolades that have been bestowed, many and substantial, and again earned and deserved, but I do hope the MDs in time get some more recognition for the work they do in medicine, which I'm involved in, but not front and center. And then conversely, I think a lot of the things that really matter to me right now in food and ag and forestry and sustainability don't lend themselves whatsoever to those kinds of awards or recognition, because we don't meet the criteria, or we're not in the scope of physics or chemistry or medicine or economy, let alone literature, right? So I think what we are focusing on right now is different and distinct in scope, in scale. I think it is remarkable. I think it is worthy of recognition and accolades, but I don't think it lends itself whatsoever to a Nobel per se. And I think what we've done in the past, has been looked at and deemed not either the work or the people deemed unworthy. And I think also it's important to kind of figure out, like, crediting people for work and or working for credit. And I think a lot of people kind of misjudge that, mismanage that, misappreciate that, misunderstand that, misvalue that. And I've gotten, to your point, plenty of awards in my life, plenty of recognition. Some would argue more than I deserve. Some would argue not enough. It's not mine to assess necessarily at this point in time, but I've gotten my fair share for sure of recognition, of awards, of accolades from my peers, which is what really matters, from my colleagues, which is really what matters. But in the end, I'm going to measure my success according to the impact that we have and our ability to translate that great science and technology into real results. And I would argue what we did, in 2000 and 2005 and up until 2010 and 12 and maybe 13, depending on how you count that, has had an impact and was great and was worthy of a lot of consideration, but was not translational and transformational as much as other people's work was. And I also think that what we're working on right now in forestry, in food and ag in general, and NC State in particular, but some of the startups that I'm involved in and working on, it's really going to have a much bigger impact in the future. And, ask me the question again in 2050.
Yeah.
We'll see where things stand. But I think we're trying to tackle problems right now in sustainable agriculture and sustainable forestry that are going to take us a long time to get to, a lot of time and effort to solve them, and we won't be able to gauge until much later on how successful we've been and how remarkable or not our contributions have been. So I'm looking for the long term right now, and time will tell.
If you could give like a approximately 1 minute answer to this question, how did you decide to start a startup instead of just continuing solely being an academic researcher?
If you really want to have an impact, you have to have the wisdom and the courage to take your ideas, your technology, and your science into the real world. Sometimes the best way to do that is to license it to partners that can take it. Sometimes the best way to do that is to give it away, let other people do it. And sometimes the best way to do that is to do it yourself.
Yeah.
And for me, in the startup world, I've realized that more often than not, I have a role to play in the commercialization of the technologies that I develop, helping other people take their technology to the real world as well when I'm a co-founder, or taking the technology and ideas and vision that I have out of my own lab, my own mind, my own hands into the real world, and doing a startup, in my case, is the easiest, the most enjoyable, the most entertaining, the most impactful means to do that. And that's what I've done, a few of those, a handful of them. That's why I keep doing it until it's not fun anymore, until it's too hard.
Yeah, because it turns it into an actual product that can be used in industry or something. So last question. If you had to give one piece of advice to a PhD student that's maybe considering becoming a professor, what piece of advice would you give them?
You have to learn to synergize and collaborate with others, because there's only so much you can do on your own. No matter how much you know, how good you are, how smart you are, how creative, innovative, motivated, hardworking you are, you're going to need to work well and synergize with so many other people to advance the science, advance the technology, manufacture it, strategize it, patent it, scale it up, make it profitable, make it affordable, make it accessible, make it clinically relevant, make it industrially, a reality. And you're gonna have to work with fellow scientists, non-scientists, and lawyers, and business people, and clinicians, or farmers, or patients, or advocacy groups, or foresters, to be able to take it to the real world. And the earlier you learn that, the better off you're gonna be.
That's good. Thank you.